Brilliant, thank you. So my name's Joe Miles. I'm from Atamate. Today I'm going to talk about how we use data to reduce energy in buildings. And to kick off, I'll just give you a quick introduction of who we are. So Atamate is what we call the next generation of building management system. And the reason we're next generation is that we're totally data driven. There's no bespoke code needed on a building by building basis. The equipment we install is actually wireless. We use a Bluetooth mesh technology. It can be installed by electricians, so it means it's much lower capital cost, and we significantly reduce the OPEX cost of the building that we're getting stored in. We've got a solutions company as well, which basically is an MEP, so mechanical electrical engineering company, and we're fully certified to do all the design and installation if required. And slowly we're moving away from doing that, and we're just focusing on the technology, which is where we want to be. We've been installed in a range of buildings, from domestic buildings right through to helicopter factory, to oil offloading terminals, to student accommodation, GP surgeries, a whole, a big range of different types of buildings. So, but I know very little about digital twins. I'm new to the digital twin community, so I've sort of shamelessly stolen some of your slide information. So the blue triangle comes off the Connected Catapults website. And what was interesting as I went through this is I realized it matched very well with how we perceive our stuff and the journey we've been on with data. So, really starting at the bottom, we've got this mesh network. We predominantly are picking up sensor information in each room of the building. So typically collecting temperatures, humidity, air quality, ambient light levels, vibration, noise levels, air pressures, a lot of information coming off the building or in a room level. Also metering information, so really granular metering information. And then on top of that, we obviously know when devices have been turned on and off because we're controlling all the mechanical systems in the building. That data then gets pushed up to what we call a hub computer, and a hub computer then is what you guys would think of as an edge computer, and there might be multiple of these in the building, and they have, not only do they control the building, but they also push that data up into the cloud. And that's where it sort of gets more interesting. So that's what the Catapult's calling sense making. We call it surfacing the data. And when we start to surface the data, we can see what's going on. And off the back of that, then we can start doing things with the data. And those tend to be alerting people of things going on, API links to third-party systems, and then machine learning as well. So I'm going to jump into some data now. So first of all, just looking at some occupancy-based heating. So I've just grabbed some these screen grabs. And as we can see on the left-hand side, we've got essentially a thermostat working. So this is controlling the temperature in this room. And here, this is an electric heater that's being turned on and off, and hence the sort of pink color. So it's being turned on and off to hold that temperature constant. And then we've got the occupancy, and all of the occupancy in our system is a combination of passive infrared. So that's like a burglar alarm type sensor, and also carbon dioxide. So those two sensors together is how we produce an occupancy level. What we've done here is we've turned on the occupancy-based heating, and as you can see now, the temperature profile varies depending on the occupancy. And just bear in mind that depending on the fabric performance of the building, the setback temperature we might not just turn off the heating, we might retain the heating at a certain level. So particularly if it's very cold outside, and that's why you're not seeing the heating go totally off, but you're seeing it drop down to a lower level in this building. And again, you can see there's continual occupancy. So this is a sort of example of heating. One of the problems, and I thought I'd just bring up one of the alerting issues that we've recently dealt with, and that's we see a lot of the student accommodation. And this is where if you start controlling the heating well in student accommodation, the students go and buy portable electric heaters. And so the management wanted a way of detecting these because they're a fire risk to the building, and also you end up with runaway energy bills. So here we've got another time series of data coming across. And this is the kind of granularity of information we're getting out. So you can start seeing, sorry, it's quite small here, but these different colors on the bars. The dark blue represents cooking, the dark green is showers, but obviously it's dominated by this orange color. And the orange color is the sockets, essentially. So it's the socket load in that space. And if we then go and look at that compared to the energy use in the building. So again, the time series data, you can see quite clearly that now we're exceeding our set point. So the temperatures in that room are exceeding the set point, and at the same time, there's no the heating's not being turned on and off in those spaces. So essentially that means that the only way you can be reaching those temperatures is a secondary use of heating. So we're very confident that in this building, or in this room in particular, sorry, in this room, they're plugging in portable electric heaters and the problems associated with those. So off the back of this, and we can create alerts, we can tell management that those sort of problems are happening. And so and we can create those alerts on broadly anything in the building. And in some, we've kind of got 5 value propositions that we do. So the first is very much around energy. On top of that, we do maintenance. So there's real-time sort of maintenance information coming off. You've got the management information shown here. There's also security information and things like door entry. And then the final one is around wellness. So I was just going to give you an example of wellness in the building. So here, what we're seeing another time series of data. This time we're looking at carbon dioxide levels. So you can see these carbon dioxide levels are fluctuating wildly. The humidity also is fluctuating. So this was controlled on to a lighting circuit essentially at the time. Temperature, we can broadly ignore this for this, for this use case. You've got the occupancy as before. And at the bottom, we can see when the fans have been turned on. So this is showing you when the fans are turning on and off. And if we look down before this, the average across this time period at the beginning, we've got both the occupied air quality or carbon dioxide levels and the unoccupied. And I mean, you probably can't read it, but that's saying, 1,300 parts per million. That's nearly 1,500 parts per million, 1,000 parts per million. So, somewhere around probably 1,100 or something parts per million, a sort of average level. So then we turn on the ventilation controls based on carbon dioxide levels. So we're now controlling it on, the air quality in that space. And as you can see, the air quality, suddenly smooths out enormously, the carbon dioxide levels. There's still occupancy in the space. So the reason it's spread out is not because there's no one in the room. You can see there's still occupancy there. You can see the fan is going on a lot more often. And then at that point, we can see that the air quality is improved. And it's now sort of averaging that, for people who can't see it, the occupied carbon dioxide is around 600 parts per million, 700. So, we're down at the 680 something, parts per million level. So significant, improvement in the space. So those are just a couple of examples. I thought I'd just finish off because, again, my low knowledge of digital twins is I can see that connected digital twins are a big thing for the community. And this is a kind of overview of the architecture of our system in a fairly simplistic way. So we've got all these devices down the bottom, which are then feeding into the Atamate hub, which is our edge computers, it's the local machines, which is doing the control and also pushing all that data into the cloud, which then allows two-way processing back down into the hubs as required. But we can also have API links into third-party systems. So CAFM is computer-aided facilities management system. So these are databases that allows, you can then get your electricians and plumbers to go out and fix problems, and obviously booking systems. So it might be a hotel booking system, but essentially we can link into almost, within reason, any third-party system through an API link. So I don't know how I'm doing for time, but that's basically me done. I really welcome any sort of feedback. We're very new to this community. We don't have any sort of digital twin background, so interested in any feedback, comments, and clearly anybody who's got a portfolio property who wants some benefit in controlling and reducing emissions, be very keen to talk to you as well. So thank you very much.
So Joe, our first question highlighted in purple is for you. It says, how secure is Bluetooth mesh? Is it vulnerable to hacking?
Okay, I'm not a technical person, but so I can't give you a technical answer. And obviously it's all available publicly on the Bluetooth forum. But my understanding, it's bank grade level encryption on the Bluetooth mesh. Essentially, it's very, very high level of security. And I mean, quite frankly, it's such a high level of security, it's quite a pain in the butt to install it because there's quite a lot of sort of hoops and such like we have to jump through. When you're installing Bluetooth mesh, you have to provision all the devices, so you have to join them all together in the same way that you would join your headset to your phone, or more point, probably your phone to your car, and you have to put in a code number type thing. So this is done at a bigger scale. So and it can be quite challenging. So one of our big technical hurdles to get over is how to do that simply for electricians to allow third parties to do it. And the challenge was simply because the security level on Bluetooth is so high. But I'm afraid I can't tell you anything more than that because I'm a builder, not a software person.
So we'll go next to our next question, Joe. Is how many sensors? How do you manage the asset tags of sensors? Challenges in knowing where all the sensors are physically located.
Yeah, okay. So how many sensors? I mean, we put in sensors because of the value proposition that we're going to give the building owner. So it will vary on what the building's being used for, and we will vary the sensors according to what we're trying to achieve, and what, or more to the point, what the customer's trying to achieve with the building. So, but I mean, typically in a typical building, we're putting in what we call a ceiling sensor unit, which has got 10 sensors in it into each room. And on top of that, you're going to have additional sensors which can be, linked in plant rooms and also pipes. If you want to detect Legionellas or something, maybe in a hospital, then you'd have Legionella type sensors on. One of the big advantages using Bluetooth is that there's a lot of energy harvesting technology. So we can use third-party energy harvesting software that allows us to grow that. So I'm still getting feedback on this. It's very bizarre, but anyway. The second question about how do you manage the tagging of all the sensors? Well, we don't tag them because we've got our own design tool. So we would we actually have a no-code design tool for the whole BMS system. So before it gets installed, we would basically design the whole system, and then we have a common config file which is goes on to both the edge computers, our hub computers, and it's also in the cloud. So all the data is totally unified, and we know exactly what all the data is. So there's no manual tagging at all on any of the buildings. We don't, tagging is not really a word we use because we know the addresses of all the systems that we're putting in. Do we have a challenge in knowing where the sensors are? No, because we've designed the system. So, we are building service engineers, so we are doing it to solve a problem. We're not doing this for intellectual, fun. We're doing this because customers have got real problems. We're finding that we're getting a lot of customers at the moment which want to sort of decarbonize their buildings, which basically means they're removing gas and oil boilers. And so, and that's actually how do you do that? Is that the best way to do it is have a data set. That data set is going to then inform you of not only your fabric performance, the occupancy use, how quickly you can control things, and from that you can then determine what mechanical systems you're going to use. So, when you're replacing a gas boiler, you might want to use a air-to-air heat pump, might use a air-to-water heat pump, you might be using direct electrical infrared, that type of thing. So we are very, very specific in what we're trying to achieve. And we built the system that we can deliver this, affordably. And typically our cost prices is...
Thank you, Joe. Sorry, Joe, we have to move on to the next question.